So today we'll cover the app that me and my mentor created. And it's basically a stock prediction app. And it was created by me and my mentor, Steve. So today we'll be covering the motivations behind what I created, how the data was collected, processing the data, the difficulties that we faced, and the lessons that I learned. So basically, the motivations behind the product was that I was curious. I wanted to know how the stock prediction was created. I want to know how other stock market predictions were created. I want to use this program in real world applications where I can get real life stocks and use them to run my program. And the data sets were relatively quick to find. And I wanted to know how large amounts of data were processed. And I was able to use data by creating a model to process the data. So basically, we're going to go over how was the data collected. So the data was collected by Kaggle. Kaggle is a well-known website that allows users to find and publish data sets that can then be used by others for their own purposes. And among these, you can find many stock data sets, and the process of making the model, I used a really large data set, and the data set had stocks and prices from all the way from the 1970s to all the way 2017. So after just obtaining one stock after obtaining just one stock data set, I was able to create a stock predictor. So we're going to go over how was the data processed. Now this took over a course of many steps, but we'll break it down into a couple of simple types. So first we turned the data into a data frame where we used pandas, turning the data into data frame, which was really simple because we just used the read function. Then we separated the data where we only used two columns, the closing price and the dates. This is because the closing prices nearly match the open, highs, and low prices of the daily price of the stock. And then next, the data from 1970s was inconsistent with recent times, meaning that the data from 1970s were just too big of a gap from the data relatively recently in like the past 10 years. So what we had to do is that we had to cut out a large chunk of this data from all the way from initially from 2009, then we changed it to 2012 to make our predictions better. And then so we had data from 2012 to the current recent price of the stock, according to the data. And then next we turned dates into timestamps. So we need to convert the dates into timestamps because it's really stored as a string, as the data and the string for the dates. And so we want to turn it into a time so that it can store the information as time. And then we split the data into testing data and training data, where we trained on our data, and then we finally put our program on our testing data. Next, we created a sliding window. In this case, sliding windows are sublist, if no one knows, and they're used to basically run over arrays. And basically, the sliding window is needed so that we can create a mean average, so we can create our future predictions. And finally, we're establishing our model. Here, the Keras library was essential, where we could implement the running neural network, or the RNN, to process the data and establish the kind of graph and the averages to create a trend for the data, and thereby we can create the final predictions. Next, and the last final step was processing the results or plotting them. So we used the matplot library to clearly present out our predictions, and with that, we compared reality, our true predictions, to the predictions that our program made. So turning the data into a data frame, this is our program, where we pretty much essentially imported a lot of these libraries, and then we just used the read function. So that read function created a data frame, and here we ended up dropping out a lot of the other columns, like the open int, volume, low, high, everything except the dates and close. And here below that, we pretty much cut out any date before 2012, January 1st, and we keep that data all the way up to the end date. Next, we turn the date into timestamps. So using this code below, we convert the date into timestamps. Then we split the data into training and testing data. Here we take around 80% of the data goes into training, 20% goes into close. And then here we create a sliding window where we use a for loop, an if-else statement, the range, and then we have our NumPy arrays on the train assigned to variables. And then here we have establishing the model where we use the keras function. And right over here is that we run using the regressor, we run our data through several neural network loops. And here, each time the data is going through that loop, is getting a more accurate prediction. And so basically below is where we compile, and our training data right here is where we train our model. And then that gets our predictions. And then here we have plotting the data where we have our predictions labeled as green and our true predictions, reality, is labeled as red. So we're going to talk about the difficulties now. The difficulties were that we cannot use all the data because obtaining prices were extremely different from 40 years ago. So instead we took data from 2012 all the way to the most recent date to find kind of like the best growth and the best average recently for recent times. And basically the data predictions initially did not match the true predictions at the start. Experimental trial and error occurred frequently. We were going to do 2009 instead of 2012, but it turned out 2012 was slightly more accurate. And so it's not a perfect stock predictor, but it can be improved, and it does do some solid predictions. So we're going to go over the lessons that we learned. So I learned how to use a variety of Python libraries such as pandas and keras. I learned how to organize data into a charts and how to differentiate the data into different colors. And lastly, I had a fun time learning about machine learning and basic neural networks. All right, so now we're going to go over to see how, or a demo of the program. So here we go into our stock prediction now. And then, as you can see here, we need to upload a CSV file, a TXT, or a XLCXSX file. And we need to have a column with dates and a label with the closing prices. So we're going to go into browsing files. We're going to click on KO, which is, well, we're going to click on Apple. So this is Apple, if we want to open it. Then we're going to see all of these columns. And the most important one we're looking at is date and close. And basically, we're taking our data, it goes all the way to 2017. Basically, we're going to upload this. And it's going to start training. Now, this does take a while, like it says. It does take up to a couple minutes. So that is something that we should probably improve, something that we can do better on the stock prediction. But yes, so this will continue on for a couple minutes. All right, so I think it should be finishing up about right now, maybe in a minute, 2 more minutes. And so this whole kind of programming of the app actually took maybe 5, 6, 7 weeks of actual programming. The first 3 weeks were really just learning about Python. And just as a note, this entire prediction app is just based on Python. Nothing, no other language was used, just pretty much all of Python. But we did use quite a few libraries. So that is something that was beneficial for me and hopefully beneficial to you. All right, so we finally have it. This is Apple's stock prediction. Now, so this is their stock prediction for the next 3 days. As you can see, it kind of just decreases by kind of a couple cents. It's not really that much. And this has happened, of course, over the next couple of days. And so below here, we see our prediction trends and the truth, the real trends. So basically our prediction does fairly well. It does drop, but not drastically. It does kind of recover and does bounce up, but not as spiky. So obviously there is room for improvement, but it does do really well. It does fairly well, giving some pretty accurate predictions. And on top of that, the more recent data that you can use, the more recent data you can find. So this data is really just taken from up to 2017. Is it so? And yeah, and using the most recent data, we'll probably get the best results. This data, this TXT file is all the way having data from up to 2017. Newer data sets will probably yield better results. So that's all for today. And thank you for listening to my stock predictor.